Okay, so I'm going to teach you about exponents, and so I'm just going to teach you this. So we have negative 0.257 to the 0 power. Well, you need to know anything to the 0 power is 1. Anything to the 0 power is 1, and the opposite of 2.57 to the 0 power is going to be negative 1, okay? Because it's the opposite of anything to the 0 power of 2.57 to the 0 power. So remember, anything to the 0 power is going to be 1. Okay, now we're going to look at negative exponents. So when you have negative 5 to the negative 2, negative 5 to the negative 2. So with a negative exponent, first of all, you don't want to have a negative exponent. Okay, so when it's raised to a negative exponent, that means it's got to be a fraction. So this actually, to change that negative exponent to a positive, you put it as a fraction and you put that as a denominator. And now that exponent becomes a positive. So we have 1 over negative 5 to the second power. And now we can simplify it even more. Well, we know negative 5 to the second power is negative 5 times negative 5, which is 25, because a negative times a negative, remember, is a positive. So our answer here is 1 over 25. So negative 5 to the negative second power is 1 over 25. Let's do another one. So if we have 2 to the negative 6, so we have a negative exponent here, and remember, to change the negative exponent to a positive exponent, we write it as a fraction, 1 over 2 to the 6, and then we say, well, what is 2 to the 6? That's 2 times 2 times 2 times 2 times 2 times 2. I think that's 6, whatever, multiplying repeatedly by 2 is 6 times. And I think that is 64. So this answer would be 1 over 64 as the final answer. Okay. Here it actually wants you to find the missing number. So 4n to the what power would give you 4n squared. Well, if you notice the difference here, that n squared became in the denominator. So that means that this would be a negative exponent, and it's the same number. So the actual missing number here is negative 2. 4n to the negative 2 equals 4 over n squared. So that 2 doesn't change. We just know it's a negative exponent up here because it's in the denominator here. Another one, if we have a to what power? Okay, for this one, let's do the b first because of the question mark. We noticed that it went from a denominator to the numerator. So I haven't taught you this yet, but for negative exponents, if it's in the denominator, the negative exponent, you can make it a positive exponent by putting it to the numerator. So if it's in the numerator, you switch it to the denominator. If it's in the denominator, you switch it to the numerator to make that exponent positive. So since it became a positive 3, we know that this down here had to be a negative 3, okay? So it equals b cubed over 3. But then we're like, well, how do I get rid of, or how did this 3 stay on the bottom here, but the a was gone? There's no a in my final answer. Well, a to the what power would give you 1, because technically there's a 1 right here in front of that b, right? But we just don't ever write it because it's always understood. Well, how do I make a just go to 1? Because that 3, this moved up here, but the 3 just stayed the same, and there's nothing else there, so obviously a became a 1. So a to the 0 power becomes a 1, just giving you a to the 0 over 3b negative 3 will simplify to b cubed over 3. Let's do one more for negative exponents so you can understand negative exponents. So when you have negative 4 to the negative 3, remember to change this to a positive since it's in the numerator, because it is in the numerator, because we can put anything over 1, and it's a fraction. So we need to put this in the denominator to make it a positive exponent. So 1 over negative 4 to the third power. Now we can simplify it. Negative 4 to the third power. 4 times 4 is 16. Then 16 times 4 is 64. Yep. So 64. So that would be 1 over negative 64, because negative 4 to the third power is negative 64. Now, like I said, in your final answer, you cannot have a negative exponent. So I want you to simplify this. This negative exponent goes with the x. So the 5 would stay on top, would stay the same, but the x would now move to the denominator to make that a positive exponent. So 5x to the 4th. Another one like that would be 1 over x to the negative 7. So the negative exponent is down here on the denominator. To make that a positive exponent, we're going to move it to the top. So my final answer here would be x over 7. And we don't need the 1 because 1 times anything is just itself. Okay, so that's simplified there. If we want to simplify this, we just need to make sure we simplify everything. First of all, we're going to simplify the negative exponents. So the x squared stays on top because it's already a positive exponent. But we're going to change the 2 to the negative 3 down to the denominator, and it'll be 2 to the third. And then this z to the negative 7 will also move down to the denominator to be z to the 7th. We can actually simplify this even more because we have 2 to the third, which is 8. So our final answer will be x squared over 8z to the 7th. Okay? X squared over 8z to the 7th. Okay, when you're simplifying, just like I said before, you want to always start with the negative exponents, and then we can simplify even more after that. So we see t to the negative 5, so that's going to move down to the bottom. And we see 2 to the negative 1st, so that's going to move up to the top. So let's rewrite that. So 2 to the 1st, it becomes a positive exponent, times 7, and then we have s to the 0, and then all over m squared, and then the t to the 5th moves down. We can't simplify the denominator anymore because we don't know what the variables are, but we can simplify the top because 2 to the 1st is just 2, and 2 times 7 is 14, and we know s to the 0 is 1, so 14 times 1 is just 14, so we have 14 over m squared t to the 5th. So that would be our final answer. Okay, let's say that we have this 2 to the negative 4th times negative 3 to the 3rd times 5 to the negative 2nd. First of all, you want to always simplify the negative exponents again. So this 2 to the negative 4 will become down in the denominator, and it'll just become 2 to the 4th times 5 squared. And then that negative 3 to the 3rd will just stay on top since it's already a positive exponent. Now we just got to do it. Negative 3 to the 3rd is a negative 27 because that's negative 3 times negative 3 times negative 3. And then 2 to the 4th is 16. And then 5 second is 25. I'm going to cheat here with my calculator. Not really cheat. I'm just going to plug it into my calculator. 16 times 25 is 400. So my final answer is negative 27 over 400. Okay, now I'm going to teach you exponent property rules. So when you have the same base, so these are both c's, and that means multiplication when they're side by side. So we have c to the negative 2 times c to the 7th. You can simplify this by adding the exponents. So the rule for multiplication of exponents with the same base is that you add the exponents. So you say negative 2 plus 7, and that becomes c to the 5th when you simplify it. Okay, so you add the exponents when you're multiplying exponents with the same base. For another example, if we have b to the negative 2 times b to the 4th times b, so they all are b, so they all have the same base, and we'll multiply them. So we do the exponent property of adding the exponents. So you say negative 2 plus 4, which is 2, and then this exponent is 1, so it's understood as 1. So negative 2 plus 4 is 2, and then 2 plus 1 is 3. So the simplified answer would be b to the 3rd. And then if coefficients start playing or start in the in the mix, the first thing you want to do is sorry, that was t to the negative 5, is to actually simplify if there's multiplication in between. Here, you can either simplify the negative exponents first, or you can just multiply them and do the exponent rule. It doesn't matter, I'll do both ways. So 5 times 2 is 10, and then negative 2 plus negative 5 is negative 7. And then I need to simplify the t to the negative 7. Well, the 10 stays on top, but t to the 7th goes on bottom. Okay, now let's do where I simplify the negative exponents first. So 5 times 2 stays on top, and then we have t to the negative 2 times t to the negative 5 Okay, so now let's do it the other way where I simplify the negative exponents first. So we have 5 times 2 that stays on top, and then the t to the negative 2, once it goes on bottom, is just t squared, times t to the negative 5, once it goes on bottom, it's just t to the 5th, and then we can simplify it. We'll still get the same answer. 10 over t to the 7th, because, that's a t, t to the 7th because 2 plus 5 is 7, and remember, when multiplying with the same base, we add the exponents. Okay, so here we're going to, so if you notice, there's only one with the same base, x and x. This y we can't simplify because there's no other y's. So we can combine these two right now with the x's. So 5 times 3 is 15. And then we have x to the 7th power times 3y to the 6th. And we got 7 because 5 plus 2 is 7. Now in this case, we can combine these. We can't combine the variables, but we can multiply 15 times 3, which is 45. And then we have x to the 7, y to the 6. So this would be simplified. The next exponent property law that I'm going to show you is when you have a power raised to another power. So c to the 5th raised to the power of 2. With these exponents, you actually multiply them. So when you have a power raised to another power, you would multiply those exponents. C to 5 times 2 is c to the 10th. Okay, so that's simplified, c to the 10th. So you multiply when you have a power raised to another power. So it gets a little tricky when you have something like this. And then, so it gets a little tricky when you have t to the squared raised to the negative 2 or t to the squared raised to the negative 5. You can actually simplify the negative exponents if you want to first, but in this case, I actually think don't simplify the negative exponents yet. Always simplify the exponent property law first before you do the negative exponents. So here, a power raised to another power, you multiply them. So 2 times negative 2 is a negative 4, times t to the 2 to the negative 5 is negative 10. We still have an exponent property law where if it's multiplying by the same base, we add the exponents. So t to the negative 14, because negative 4 plus negative 10 is negative 14. And then I can simplify the negative exponent. So then I can do 1 over t to the 14. Because it is a negative exponent, so I put it down on bottom. That's the easiest way to solve these problems is, again, when you have an exponent property law first, simplify the exponent property law, and then you can simplify the negative exponent. Okay, with this one, we're going to simplify the exponent property law first when we have a power raised to another power. But in this case, we have more than one item, one term, in the parentheses. So you kind of have to use distributive. You have to distribute this negative 3 to everything in the parentheses. So you have to distribute it to the 2. So it'd be 2 to the negative 3rd power. And then you also have to distribute it to the y. So it'd be y to the 4th time to the negative 3rd power. And the reason why it's 2 to the negative 3rd power is because there's a 1 right here. And 1 times negative 3 is negative 3 because it's a power raised to another power, so you would multiply it. So I'm going to simplify it even more. 2 to the negative 3 times y to 4 times the negative 3 is negative 12 because it's a power raised to another power, so we multiply. Now I'm going to simplify my negative exponents. So it'd be 1 over 2 to the third y to the 12th. I just put them down at the bottom to make them positive. And then I can actually simplify even 2 to the third even more. So 2 to the third is 8. So my final answer is going to be 1 over 8 y to the 12th. 1 over 8 y to the 12th. Now the last exponent property law that I'm going to teach you is when you are dividing with the same base, when they have the same base. So remember when they had the same base and you were multiplying, you added the exponents. So the inverse of adding would be subtracting, since the inverse of multiplying is division. So obviously you would do the opposite as well to the exponents. So you're going to subtract these when dividing with the same base. So 8 minus 3 is equal to 4 to the 5th power. So this would simplify that, and then you would simplify that and actually write it out. 4 to the 5th power is 1024. So that's my final answer. Now when it gets tricky is when you have more than one exponent property law in but you got to follow PEMDAS too. Okay, so since this is divided by everything on top, you need to simplify the top and you need to simplify the bottom separately. So let's simplify the top first. This is the exponent property law of multiplication of the same base. That law said that we added the exponents. So 10 plus 20 is 7 over 30. And then down here, we have the exponent property law of a power raised to another power. So remember that law said to multiply the exponents. So 14 times 2 is 7 over 28. And then we have the exponent property law of division where it says to subtract the exponents. So we have 30 minus 28, which is just 7 squared because 30 minus 28 is 2. And then we can simplify that even more. 7 squared is 49. So my final answer here is 49. Another thing that I'm just going to teach you really quickly is if you have 4 to the negative 2 divided by 4 to the 8th. Let's say we have 4 to the 8th. Remember how I said don't simplify the negative exponent until you follow all the exponent property rules if there are any. If there are not any exponent property rules, then go ahead and simplify the negative exponents first. But since there is an exponent property rule here of division where we subtract the exponents, I'm going to do that first. Negative 2 minus 8. So that would be negative 10. So we get 4 to the negative 10. 4 to the negative 10. And then we can simplify the negative exponent where we get 1 over 4 to the 10th because we have to put it in the denominator. Then 4 to the 10 is, so we have 1 over 104,8576. So that's 1,048,576. So that would be 1 over all of that, 1 over 4 to the 10. Okay, so that is exponent property laws and also negative exponents. I'm going to do one bonus problem just so you know it. So we have negative 2a squared b all raised to the third power and ab raised to the third power. In this case, you're going to distribute that exponent to everything within the parentheses. So here, I'm going to distribute that 3 to the negative 2. So it'd be negative 2 to the third power. I'm going to distribute it to that a, so a squared to the third power, and I'm going to distribute it to that b, so b to the third power. So I distributed that 3 to everything in the parentheses. Now I'm going to distribute this 3 to everything in the parentheses. We get a to the third power and b to the third power. Now I'm going to apply the rule, a power raised to another power, and multiply those exponents. So well, here I have negative 2 to the first to the third, so it's just negative 2 to the third, and I can just go ahead and simplify that. So that would be negative 8, because negative 2 times negative 2 is 4, and then 4 times negative 2 is negative 8. Here, let's simplify it. A to the second to the third, multiply those. 2 times 3 is 6, so a to the 6. And then here, remember, understood as 1, so that would be b to the 1 times 3, which is b to the third. Over here, same, it's understood as b to the a to the first and b to the first. So a to the 1 times 3, it would just be a to the third, and here b to the first, 1 times 3, b cubed. Now I can simplify this because this is all multiplication, and multiplication, if it had the same base, we add the exponents. So I can add all the a exponents, so 6 and 3, which is 9. So we have negative 8, a to the 9th. And then for the b's, we have 3 and 3, which is 6. So b to the 6th. And then I have it simplified.